Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the already proven differentiation rules in computing the derivative of this given function. For this video, we can see that our given function is a product of two different functions. Hence, we are going to use the already proven rules in differentiating product, and of course we'll be using the rest of the rules in differentiation, which involves constant multiple, and even power. So let's start by copying here our given function. F of x is the product of 2x squared plus 9x, and you will have here 11x minus 1. Now, for some, they don't want to use a rule on products. So they tend to multiply this using FOIL method, and whatever be the result, they will just use the rule on sum or difference of functions. That is okay, as long as you can make sure that the product of these two is correctly written. Because if it's not, then definitely you will end up with the incorrect derivative. So here, let's just simply use the derivative of product of functions. In the proof of the said rule, we used h of x is equal to the product of f and g of x, right? But since the given here is f of x, let us of course denote this as f of x be equal to the product of g and h. Please do not be confused this with the rule that we have proven already, but the point here is we are multiplying g of h this time. So the rule for differentiating a product is, of course, we're going to use here this one. We are going to take the derivative of the first function times the second function plus the derivative of the second function times the first function rather. And of course, since this is addition, you can just interchange them, whether you want this first or this, and of course you can also interchange them because there is also commutativity for multiplication. But nevertheless, the point there is multiply the derivative of one to the original of the other, and then reverse it, and then you add both results. Okay? So in this case, if we're going to use this, our g of x on our given function, let us have it as 2x squared plus 9x. So our goal is, of course, to get the first derivative of this. Hence, or let me move this a little bit lower so that we will have a lot of space here, f of x here. Okay, but one of the requirement is the derivative of g. So in the meantime, for a separate piece of paper, let us get the derivative of each of the two functions. Here, this is constant multiple as well as here. So you will have your 2 times the derivative of the power. Take note, I am blurting here some of the rules that we have already proven. So you have 2 times x, 2 minus 1. Okay, plus you have 9 times x, 1 minus 1. Okay, that's the rule for constant multiple and power, which will give us a result equal to 4x to the power of 1, or simply 4x, plus 9x to the power of 0, but since it is equal to 1, you can simply leave 9 there. So we are down to this already. We already have h of x. Oh, that's our h of x, the next item here, which is 11x minus 1. What we need is h prime of x. So you will take here again this constant multiple. You have 11x to the power of 1 minus 1. Take note, this is 11, and the derivative of the constant, which is 0. Okay, so you will have here the derivative of h, which is 11x to the power of 0, which is just 1 minus 0. So you have only 11. Take note again that our formula or the rule for differentiating product, you can take this, the derivative of the first times the second plus the derivative of the second times the first, or if you would like this first times that. Again, commutativity works here. So simply substitute g prime of x, or the first derivative of g is 4x plus 9 times your original h of x here. You have here 11x minus 1 plus the derivative of h of x, which is 11, times your g of x originally as 2x squared plus 9x. So simply try to combine all of them. This will need you to use FOIL method or a product of two binomials. So bear with me, you will have here 44x squared for your first term, outer terms is minus 4x, inner term is plus 99x, and last terms is minus 9. Plus, simply distribute that 22x squared plus 99x. So a little bit large, but of course, let's simply continue here. 44x squared plus 22x squared is 66x squared. You'll have here this one and that, so you will have 95 plus 99. You could add them up, you will get 194 plus 194 if I'm correct. Let's see, 99 plus 99 is 198 minus 4. Okay, we will have 194x minus 9. This is our derivative for this given function. Okay, so this is already okay, but of course, as mentioned earlier, for some who don't like product of functions, they tend to multiply this first to get another separate f of x. So by FOIL method, you will have 22x cubed. Outer, you will have minus 2x squared. Inner, plus 99x squared. And you will have your last terms minus 9x. So you can have here f of x is also 22x cubed minus positive 97x squared minus 9x. And using this, you will just simply need to use the rule on sum or difference. So your f prime of x, and let's see if this is the same as this. Okay, if we will have the same answer. So this, using constant multiple in power, 22 times 3x, 3 minus 1. You have plus, let me erase this. Okay, so we are using this, okay, just to illustrate. You can also try this on your own. 97 times 2x, 2 minus 1, and minus 9. X, 1 minus 1, okay, so that's here. So you will have here 22 times 3 is 66, x squared. 97 times 2 is 194, x to the power of 1, and minus 9, as this is x power of 0, or simply equal to 1. As you can see, you'll have the same result as this and that. So basically, you can attack this in two different ways. However, again, as mentioned, need to make sure that if you would really like to use this method, make sure that your FOIL method or multiplying of two binomials is correct. Because if this, say for example, if this is 98, of course, this will be different from that. And if this is what your final answer is, definitely you made it wrong. So make sure that your process of multiplying them is also correct in the first place, so that you will yield the same result. But definitely, for this video alone, this is by the use of product of functions. Thank you very much for watching. So what are you waiting for? Subscribe now!